all seen it in the movies. A teenager gets bitten, puts on a mask, and swings through New York City using webs shot from his wrists. It's peak sci-fi, but what if I told you the science behind it is actually real? In fact, the material produced by a common garden spider is so biologically advanced, human engineers are still struggling to copy it. Today at LifeSpecsLab, we're decoding the impossible mechanics of spider silk, and why it's pound for pound stronger than structural steel. Let's put it into perspective. If you had a strand of spider silk thick enough to match a pencil, it could theoretically stop a commercial jet in mid-flight. It has a tensile strength comparable to high-grade alloy steel, and it's tougher than Kevlar, the material we use in bulletproof vests. But here's the crazy part. Steel requires blast furnaces reaching thousands of degrees to forge. Kevlar requires toxic chemicals in high-tech labs. A spider? It makes this super material at room temperature, using dead bugs and water. So, how do they do it? It all happens inside a microscopic factory in the spider's abdomen. Special glands store massive protein molecules called spideroins as a thick, viscous liquid, essentially, a protein soup. When it's time to build a web, the spider pulls this liquid through tiny organs called spinnerets. As it travels through these microscopic tubes, a sudden drop in pH combines with intense physical tension. This chemical shift forces the proteins to untangle, align perfectly, and cross-link together. In a fraction of a second, that liquid soup transforms into a solid, incredibly strong thread. And they don't just have one type of web. Think of it like a 3D printer with multiple ink cartridges. A spider can produce up to 7 different types of silk depending on what it needs. They have the dragline silk, which acts as their safety rope. This is the one stronger than steel. Then, they have a completely different, sticky silk used specifically to trap prey. And another super soft silk used solely to protect their eggs. They are switching these materials instantly, on demand. If it's so perfect, why aren't we wearing spider silk clothes or building bridges with it? Well, we tried, but you can't farm spiders like silkworms. Spiders are highly territorial and cannibalistic. If you put thousands of spiders in a room together, you won't get a silk factory. You'll just get one extremely fat, victorious spider. Scientists are now trying to genetically engineer bacteria and even goats to produce spider silk proteins, but we are still years away from perfecting what nature does effortlessly every single day. Nature is the ultimate engineer. What other impossible biological mechanics should we decode next? Let me know in the comments below. If you want to see how a bird can dive faster than a military fighter jet, click the video on your screen right now to check out our breakdown of the peregrine falcon. Don't forget to subscribe to LifeSpecsLab for more deep dives into the wild. See you in the next one.